Thanks a lot for the warm introduction, Murthy. Really appreciate it. So I'm pretty excited to share some of share some insights from the things we've been working on at Salesforce Research and the specific org I work with, the interactive AI org. They work on both building generative AI applications for NLP and also like evaluating existing systems. So the kind of work we do involves both, on the modeling side, on the data side, and also on the side of evaluating systems themselves that use NLP. Thanks for the introduction, but I won't spend too much time on this and just quickly dive into some background. Like you said, I work at Salesforce Research where we do interactive AI and some of the things we work on. Some of the very specific things I've built an expertise on in the last 3 years is conversational AI, text summarization, dialogue summarization, and how NLP for search works. I was an MS student at CMU's Language Technologies Institute, which fueled my interest in working in NLP and language. And before that, I interned with Uber and their customer obsession team to build agents that help customer interactions. I'm also an AI consultant with Ethical Intelligence, where we work with small startups and different companies to ethically assess their AI systems and ensure that they are developing in a secure and a responsible manner. And you can find me on LinkedIn here. I do want to start by talking about how 2023 has been a very pivotal year in NLP, and we've seen some very interesting models come out. We saw ChatGPT come out by OpenAI, and there's been like a flurry of developments after that, where Anthropic released Claude, which I'm sure you're familiar with. It's a model that generates more responsibly, and we'll look at how Claude does that later in the talk. And we've also seen like Google come up with its response to the generative AI, revolution with releasing Bard AI. So it's been a pretty exciting year, and it can honestly get a little overwhelming as well. But I want to focus on certain aspects in this talk and keep the focus on natural language processing and talk about some basic aspects like building generative AI models and systems. How do we evaluate these systems? And like I said, I do want to differentiate between studying models as well as studying AI systems. And this is a budding field that moves into this domain that researchers call HCI-NLP. How to bridge these two domains, because now, as you can see, there's so many applications being built with NLP, with AI in general, with models like Stable Diffusion in the computer vision side of things. So in general, there are so many users in the real world that are going to be using AI systems that it's important to also look at AI systems from a human computer interaction point of view. And then we'll also look at some recent trends in ethical development which stand out to me. So let's start by looking at some basic trends in large language models. And it seems like the growth of the number of parameters of these models has been rather exponential in the last 4 or 5 years. While in 2018, people felt that models like Elmo and BERT, which had a few 100 million parameters, were revolutionary, honestly, in the way they in the way they change research and in the way they change a lot of applications by making language understanding more contextual rather than lexical. It was a big revolution, but ever since then, I think Ted also spoke about this in the previous talk, but there's been bigger and bigger models that seem to encapsulate more knowledge about the world, and they have gotten better at doing so many interesting tasks in language. But I do want to start in a basic way and talk about what LLMs for NLP essentially are. And these large language models, which are more than 100 billion parameters at this point, they are essentially models and algorithms that are trained to understand and generate natural language text. And since they can generate natural language text, they can be used to perform a wide variety of activities, like predict text, classify information in natural language, to summarize information in natural language text, and to like translate it from one language to another. And this is just the tip of the iceberg. There's capabilities like question answering that language models are good at, and so on and so forth. But when these language models contain a large number of parameters, when they scale up to millions or billions of parameters, these language models are essentially called large language models. And the idea here is that language models were good at maybe one specific task, but large language models can show state-of-the-art results in multiple downstream tasks. And this is all like work in the last 4 or 5 years that the NLP community has done, and I'm sure a lot of people here are familiar with it. But I do want to mention what fine tuning essentially is. And once you have a large language model that, or a pre-trained model that is good at multiple downstream tasks, you have the option or the ability to fine tune it, to give it some specific inputs for a particular task, and make it very good at one specific task. And even when you look at large language models like ChatGPT and GPT-4, they still exhibit properties that are more aligned with some certain tasks. They can be really, really good at summarizing information, but they may not be very good at, let's say, identifying constraints in a prompt, or generating information according to very specific requirements. It's very important to mention how this trend in NLP has put the humans back in the loop. So I don't want to dive very deep into reinforcement learning from human feedback, because I'm sure there's a lot of talks here, but I do want to mention that this is the technique that has been used to train a large language model like ChatGPT, and it's been used for various other models like Claude by Anthropic as well. And this technique essentially has put humans back in the loop with respect to development of models, which has been a developing trend in the last 1 to 2 years. But before that, we used more like automated metrics to optimize models during training. But RLHF introduced the idea that can we use human feedback itself, as a loss to optimize the model. And just to give a TLDR on how RLHF works, you have an initial language model that you're trying to train and tune, that the end user will use using certain prompts, and you have a separate model which is trained separately, called a reward or a preference model. And essentially you use the feedback from the reward or the human preference model based on the information generated by the language model that you're trying to improve. And you use reinforcement learning and the scalar value that the preference model gives you to to optimize the loss for training the large language model. And there's a lot of related research which is pretty interesting, and it gives you a sense of how we got here, how in the last 2-3 years, it's not like ChatGPT appeared out of nowhere, but how in the last 3-4 years there's been a lot of research on how to incorporate human feedback into the model training process. How can we fine tune large models with human preferences? And the one work I do want to highlight by OpenAI is on summarizing books with human feedback. So this is something that was considered as a very tough task. And in fact, this paper is based on some of the results on our data set on book summarization. And it shows how, given effective human feedback and the reinforcement learning paradigm, you can summarize large tests like books and books chapters. In the previous talk, they had also mentioned this approach of retrieval augmented generation, and I feel like it's super important to highlight that. And given that we know large language models are so good at generating, it's important to consider how just a retrieval layer before the generation can help you generate really good applications using LLMs. And how does the process of retrieval augmented generation work? So it has a bunch of components, and I'm sorry if the slide is too dense, but essentially, given a prompt or a user inquiry, you first want to retrieve some relevant documents from a knowledge base. And how do you do that? You have a corpus of, let's say, millions of documents that you want to, you have a user asking questions, but you want to ground the response, the generation response from, some specific documents in a knowledge base. So you index those articles in, you index those pieces of text in a, search index. And you first have a retriever that searches for relevant content in that, knowledge base, in that index, in that entity store. And then you use a large language model to generate a completion for those, retrieved documents to generate a response for the user. And retrieval augmented generation is revolutionary because it it allows you to scale to specific use cases and also like millions and millions of documents, and it still lowers your cost to serve a whole generative AI system. Like I said, it also allows knowledge grounding and ensures more factual consistency in generation. And we have performed experiments on ChatGPT where we realize that when it performs in context generation, where you give it some contextual information about what to generate from, its accuracy improves manifold. Retrieval augmented generation is also able to capture evolving trends, without constantly retraining a generator model, a large language model. And because of all of these things, it can also work well with out of the box large language models. And there's some cool related research that you can read, on this topic. And again, this kind of highlights how in the last 2-3 years, a lot of these models were converging towards, something that allows for more seamless generation. I want to shift the focus to designing generative NLP systems and what that entails. And it's pretty interesting because once you move away from the idea of just just move your focus away from the model to the system, you kind of realize that it's just it's just a very small component in building a system that users actually interact with. So when we build interactive AI applications, we don't just care about improving. We don't just care about how accurate the model is on a particular test set, but we also care about other things like the data that was used to label and evaluate the model, how representative the data is, how good the data is in terms of providing, in terms of aligning with the human preferences of like using that entire system. We also care about ML ops, how to manage the model, how to track different versions of it, and how to have the model constantly learn on the go. We also care about the cloud platform that hosts and deploys this model, and some of these models can be really, really huge. So we want to be very mindful of the latency and the cost to serve when we build these interactive AI applications. And this is just everything that sits beneath the application layer, where the user interacts with the model outputs in some way or the other. In our work at Salesforce Research, when we build generative AI applications with NLP, we have seen some design principles specifically stand out to us. And this kind of goes, one layer above how we build this, how we build the large language models in the first place. But it focuses more on the side of applications that the users are using. We have realized that it's very important to build reliability, first of all, because users need to be able to develop a trust with the AI system they're using, with the AI model that they're interacting with eventually. And sometimes you just have one shot at building that trust with AI applications, because users tend to not be very trusting of AI applications in the first place. But I'm sure that's changing with the recent trends in the industry. We've also seen that clarification is a very important requirement that users feel when they interact with large language models and NLP. They need help to find the source of the information that's presented to them by an AI, and that further helps build that trust. We see a lot of generative AI and NLP moving towards personalization, and personalization being one of the key applications of this technology. And we've realized that users have a very diverse criteria and preference of what could be relevant, and what information fits their use case. And I guess something that reinforcement learning from human feedback does very well is kind of rank these, the reward models we were talking about. They kind of rank the preferences of multiple human annotators to be able to generate the output. But it's very important to focus on these three design principles we've realized in our work as we build future applications in generative AI. And all of this has kind of led to a field in NLP called HCI-NLP that kind of bridges how people build AI models and how people develop AI systems where users interact with those models. So here I have an example of a summary board. This is a paper from 2020 where users have an AI model to do abstractive summarization on the left, abstractive summarization on the left, and extractive summarization on the right. And they kind of develop two different interfaces to test with users. Hey, what kind of summaries do you prefer? Do you prefer summaries that are more extractive for a certain use case? Like for instance, people might feel like on a platform like Slack, they want to have more more single source of truth in the summary that they read, versus some other chat application they use where they may not have that much emphasis on the factual correctness, right? So it's pretty interesting to see how users' preferences change when they start interacting with an AI model, compared to a traditional software engineering system, which was more, which was supposed to be more, predictive in nature and not generative. And it's also essential to look at, in the field of HCI-NLP, looks at some specific generation parameters that are essential to humans that are interacting with AI models in NLP. We see that fluency is a very important parameter, and this is something that ChatGPT does really well. And in fact, it would hallucinate information and trade off, hallucinations and trade off consistency at times for being fluent. And that's one of the reasons that people are attracted to it so much. The consistency in the generation is very important, and things like retrieval augmented generation we talked about earlier help build that notion of consistency. We've realized how important it is to satisfy constraints or satisfy specific requirements that an end user might have. And this again goes into the line of personalization and the generation output specifying certain specific criteria. And this, as we work on it at Salesforce Research, we realize that it's a very hard problem. And we've tried using large language models to identify constraints in the prompts, and they don't seem to be very good at it. So it's a two-step process of like identifying constraints and then seeing if the models are able to satisfy those constraints and how they generate. And we are actually in fact working on a library to be able to evaluate large language models with with specific constraints and how well they follow prompts. With constraints also comes the notion of safety and ensuring that the output that large language models generate in NLP are safe for the viewer, are safe for the reader or the end user. There's a lot of interesting related research in HCI-NLP, some that our group has contributed to the Interactive AI org, and some other that's just developing. There's workshops that you can check out on bridging human-computer interaction and NLP, and some interesting papers on how do you design and evaluate HCI and NLP systems. And I think that's a fascinating field with a lot of potential for the future, because now that we have large models, we will definitely have like larger models in the future, but we see that in the industry that there's a lot of applications being built around putting them into the hands of the users. I want to focus on some aspects of ethical development to end the talk. And I kind of want to distinguish first between how you could address challenges in ethical development from both the data point of view and from the model point of view. And I think a lot of research has already been done on the data side of things, and how do you ensure that the training data that you use to develop these models is free from bias, toxicity, hate, profanity, violence, etc. But there's a lot of work that has been recently done on model level techniques to develop AI models ethically. I want to focus on this one technique called constitutional AI, which essentially distills language model interpretations of some set of principles with that you can call constitutions into the reward model that we spoke about, in the reinforcement learning from human feedback paradigm. So essentially, if you have a model scoring the outputs of the language model that users want to use, you could have it score the generation based on some specific principles that follow that follow guidelines for safety and and non-toxic generation of data, so that when the model itself learns, it learns to generate a data that's not harmful. And this approach is pretty interesting because it also, if you read the actual paper, it goes into ensuring that the model also generates content that is helpful. And for that, it uses human labels, and it uses some labels from the AI model, the reward model, to also to score for harmlessness. So it's pretty interesting how they're able to generate data that's also helpful, and it's not just useless to the user, but also harmless at the end of the day. One interesting technique that I feel that recently came out by Anthropic itself is this capacity for moral self correction. And the idea here is, can a large language model critique its own output, using appropriate prompts? So if you ask AI model, a large language model, a question, you prompt it to generate some information that may or may not be ethical to generate. Can we use the same language model and give it that input and ask it, hey, is this following the guidelines that we have set for our moral code or ethical generation? And I feel this is a pretty interesting field of research that we are investing in right now. I also want to highlight different ways in which tech teams developing AI systems should be supported. And this is an article we wrote with Ethical Intelligence, and we identify ways and roadblocks in developing large language models in NLP. And this kind of becomes more and more important with the generative AI rush that we see these days. And one example of tech teams developing AI in a responsible way, I would like to point out the Firefly system that was developed by Adobe. And it's been a good example of responsible and ethical innovation in this age of generative AI, and the way they use the data, the way they attribute the data to different creators. And that kind of supports, and that kind of leads by a very good example on how to develop ethically. That's all I